Hey everyone, welcome. Today we're going to dig into something that I promise you will totally change how you look at your code. We're talking about names, bindings, and scopes. These are the concepts that really separate the pros from the beginners. If you're ready to write cleaner, smarter code, you've come to the right place. So, you've definitely been there, right? Staring at your screen, the compiler is just screaming at you, undefined variable. Or even worse, a variable somehow has a value you know you didn't give it. It's super frustrating. But here's the thing. What if I told you those aren't just random bugs? They're actually your code trying to tell you something really important about its own structure. All right, to really get this, we're going to throw the dry, boring textbook definitions out the window for a bit. Instead, we're going to use an analogy, and trust me, it's a good one. Imagine you're in charge of organizing a massive college tech fest. We're talking the biggest one your campus has ever seen, and it's all happening right inside your program. Yeah, that's right. Just think about it for a second. Every variable you declare, that's a participant registering for your fest. Every function you write, that's a specific event, like a coding competition or a robotics workshop. And you're the event manager, the big boss. You're the one making sure everything runs smoothly. Okay, so first job as event manager. You gotta get people registered. I mean, you can't have a fest with no one in it, right? This is exactly where our first two concepts, names and bindings, come into the picture. It's basically the registration process for every single participant or variable in your fest. So picture this. You walk up to the registration desk, they ask for your name, you give it to them, and they hand you a registration ID. Simple. In our code, that ID is the name. And the participant holding the ID, that's your variable. So when you type something like, say, score equals 100, you're literally giving the participant, the number 100, a registration ID called score. Now this next part is absolutely crucial. Binding is that magic moment of association. It's when we officially link that registration ID to a specific participant and give them a role. We're not just saying, here's your ID, we're saying, here's your ID and you're now assigned to the robotics stall. In code, this is the act of connecting that name, score, to an actual memory location holding the value 100. It's the official handshake. And think about this. When does this binding happen? Well, just like at a real fest, you've got two options. You've got your pre-registration people who sign up weeks in advance. That's compile time binding. Languages like C++ and Java do this. They figure out all the types and assignments before the fest even begins. It's super organized. Then you have on-the-spot entry. That's runtime binding. This is your Python or JavaScript. The binding happens during the event as the code is running. It's way more flexible, but, it can also lead to some surprises. Okay, quick recap. Our participants have their registration IDs, their names, and they've been assigned their roles through binding. Perfect. But now, as the event manager, you have another big job, security and access. You can't just let everyone wander everywhere, right? This is where scope and lifetime come in. Just think of them as the access pass you give to each participant. So that access pass, that's the variable's scope. It defines where it's allowed to go. If your pass is for the robotics club zone, you're not getting into the coding competition zone. The bouncer, which is basically the compiler or interpreter, is going to stop you at the door. It's simple. Your variable's name is only recognized, it's only visible within its designated area, or scope. And lifetime is tied directly to this. If scope is the where, then lifetime is the for how long. Your access pass doesn't just work in a certain place. It also only works for a certain time. It's valid from the start of the event until the end. As soon as that event, or that function, is over, poof, the pass expires. The variable is cleared from memory. Its lifetime has ended. Now, there are two main ways this access works. First, you've got static scope. With static scope, the rules are set based on how the code is written, how it's structured on the page. You can literally just look at the code and know exactly where a variable is allowed to be. It's super predictable. Then there's dynamic scope. This one's a bit wilder. A variable's access depends on the sequence of function calls that happen during runtime. It's all about where you just came from. It's flexible for sure, but tracking down bugs can be a real headache.
All right, let's zoom out for a second and think about this. At any single moment in your program, what can a specific piece of code see? What variables are available to it right now? This collection of everything that's visible is what we call the environment.
So, the referencing environment is basically all the valid access passes a participant is holding at one time. They might have a local pass for the event they're in right now, plus maybe a global pass that lets them into the main hall. It's the sum of everything they can access. And what about a named constant? Oh, that's the ultimate pass. It's like the VIVIP pass for the main sponsor. It's bound to a value once at the very beginning, and that's it. It never, ever changes.
Okay, so what? Why are we spending all this time talking about a tech fest? Here's why. Understanding this stuff is what takes you from being someone who can just get code to run to someone who can actually architect reliable, efficient, and bug-free systems. Let's see exactly how.
Take a look at this Python code. Seems simple enough, right? We've got a function for a coding competition, and inside it, we create a variable participant ID. Then from that function, we call another one, robotics zone, and inside that function, we try to print the ID. So what happens? If you guessed error, you're right. The code breaks. The question is, why?
And this is where our TechFest analogy makes everything click. That participant ID, it's an access pass that was created inside the coding competition zone. Its scope is purely local to that function. The second our program walked into the robotics zone, that pass was no longer valid. It's out of scope. Suddenly, that cryptic undefined variable error makes perfect sense, doesn't it?
See, this is why it all matters so much. When you get a handle on these concepts, you're not just memorizing stuff for an exam. You're learning the fundamental rules of the game. It helps you pick the right language for a job, makes learning new languages way easier, and most importantly, it empowers you to write code that is solid, reliable, and much easier to debug. I really want you to take this idea with you. Every single time you declare a variable, you're not just typing a line of text. You are the event manager. You're the one who decides who gets an access pass, where they're allowed to go, and how long that pass is valid for. It's a powerful position to be in. So you are the architect of this world inside your code. Now that you've mastered these invisible rules, what will you master next? I really hope this helps you see your code in a whole new light. Thanks for sticking with me, and I'll see you next time.